Hello and welcome to EELE 261 Introduction to Logic Circuits. My name is LaMeres and I will be your instructor this spring 2021 semester. So in this video, which is the overview of the course, the introduction to the course, kind of an orientation, what I want to cover is I want to talk about briefly what is this course about, which you'll learn throughout the semester, but I'm just going to give you a high level overview. Then I want to introduce myself because I'll be the voice in all the videos that you see that you're going to be watching this semester. And then I want to talk about what we're actually going to be doing. So what are the deliverables, what are the activities you're going to do, and specifically talk about this blended format that we have to do for one last semester. And then we'll jump into Brightspace, which is our course management system, and I'll show you around and where you can find all the material. Okay, so let's begin with what is this course. This course is the beginning of learning about computer hardware. So at this point, you probably have programmed in a language like C or C# or Python or something like that. And one of the beautiful things about the way that we abstract computer hardware is that you really didn't know what was going on underneath. You just wrote hello world, you hit compile, and it popped up a screen and you were able to say hello world, right? And you didn't even think about that you were compiling your program into ones and zeros that were then downloaded into a piece of circuitry, digital circuitry, that knew how to execute those and actually was able to interact with the rest of the computer hardware so that you could do hello world, okay? And you didn't even understand what happened, and that's great. That is one of the reasons that the computer industry has exploded so much over the past couple decades. It's because people can program computers without needing to know about the hardware, and that allows them to spend time working on using algorithms and programming techniques to solve problems and build solutions for society. So wonderful. The only trick here is that somebody has to know how their computer works because we need computers to run the software. So this course is about starting to understand what is happening in the chips that make up a computer. So the CPU, the central processing unit, the memory, the registers, the state machines, the control units, all these things that you'll eventually know about before you graduate all start here. Okay. Now, I will be straight up with you. At the end of this course, you're not going to be there yet. Okay. This is just the beginning. So this is where we just start learning about all the basic level stuff so that we can actually learn the more complicated stuff later. So you need more than this course to understand how our computer works. But we are going to do this. It's going to be a very low level circuit class. Okay. And so the circuits we're going to use are digital. So we're going to call them gates. Okay. And you'll learn about that. But we're going to actually just talk about, very basic, like here's the inputs we have, here's the output we want, create a digital circuit to do that, and then we're going to actually build it on a breadboard and then test it so you can actually see the voltages and the currents and how the circuits are actually implemented. And this will lay the foundation for starting to understand the more complicated circuits that you'll learn about in subsequent classes like logic design or embedded systems. Okay, so let me give you the overview of the course. We're going to cover 7 modules which correspond to the first 7 chapters in the book. We're going to start with just a basic overview of what's the difference between an analog and a digital system. Okay, 2 pages of the book, nothing, just to get you started. Then we're going to talk about number systems. So this is going to be kind of the entertaining part where you talk about counting in binary. You've probably heard ones and zeros are used in computers. Well, we got to actually understand what we mean by binary. So we got to actually develop a framework for number systems that can take on only 2 values. So we're going to learn to count in binary, add in binary, subtract in binary, and also look at how we can use binary codes to represent more meaningful information like negative numbers and stuff like that. Then we'll look at digital circuits. So a digital circuit is unique in that its inputs and outputs are ones and zeros. Okay, they're binary values, they're logic values. But the circuit is always analog, okay? So it's always takes in a voltage, it always has current in it. So we got to look at how the circuits actually operate underneath the hood in order to produce these ones and zeros. Then we get into combinational logic design. This is where you actually design circuitry, okay? So we're going to say, here's a description of the outputs that I want, and you are going to use design techniques to actually what we call synthesize the circuit, or actually build that circuit, design it. So you'll actually design it out on paper, and then you can implement it on a breadboard, and it's pretty awesome. Then we switch gears a little bit, because one of the things that happens is that computers contain many circuits. Okay, so they're your i9 or i7 computer or processor on your in your computer, it doesn't just have like 10 transistors on it. It's not 100 transistors. It's millions and millions, and often it's billions of transistors. So the digital circuits get too big too fast. And so we learn about the paper and pencil design approach in chapter 4. But then what we need to do is say that is how you do it, but we need to automate it and allow a computer to actually turn the crank for us. So we learn about this thing called a hardware description language, an HDL, and the one that we use is called VHDL. But we learn about how to type out the description of a digital circuit, and then we allow a computer tool, a synthesizer, to actually crank out the circuit design for us and give us essentially a schematic of what it should be implemented as. And then we can actually take that schematic and download it onto programmable digital circuitry and test it. So it's a really cool we don't know how to do everything in VHDL after this course, but it just exposes you to what you can do, and it sets you up to take the follow-on class, which is logic design, where all you do is design digital circuits in this language. Then we look at some examples of what we call medium scale integrated circuitry, and that's where you say, okay, so now you know the very basics of circuit design, you know how to do it in a hardware description language. Let's look at building some common building blocks that are a little bit bigger than what you could do by hand. And so we use an HDL to describe that. Finally, we wrap it up with sequential logic, which is really the most powerful part of digital logic. And that gives us the ability to build a finite state machine. Okay, so that's the course. And it is, like I say, it's the start of understanding computer hardware. It's not the end, but you have to go through this stuff. Every single electrical engineer, computer engineer has to cover this stuff before you can get on to the more complicated system. Okay, who am I? Now, it has been shown that it is really good to know who the instructor is, especially when you watch videos, because sometimes if you just pull a random YouTube video, you have no connection with whoever's talking. But if you even have just a small background on the person, you tend to be a little bit more engaged, and that'll help you when you cover some of the, I'm not going to say any of the material is boring, but some of the more boring material. Okay, so let me introduce myself. I'm going to go to my website right here. LaMeres is all you do after montana.edu. So I actually was born and raised in Montana, Billings, Montana, and I went to school at Montana State. So I graduated with an electrical engineering degree back in the 90s, and I went to work for a company called Hewlett-Packard. Now they're called HP, but I worked there for 8 years in Colorado Springs, where I designed digital hardware. So I worked doing what we're going to do in this class. I used every single bit of the information that I'm going to show you, that I'm going to teach you. Okay. And then as big companies do, they'll pay for you to take classes, nights and weekends to better yourself. So I went ahead and chipped away at a master's degree and ultimately a PhD in electrical engineering. So I did that while working full-time for 8 years. And once I had my PhD, I was kind of looking around at like, what could I do to not only just be an engineer and design stuff and do research, how could I integrate teaching into my career? And so a natural extension of that was to become a professor. So a professor teaches half the time and does research or engineering the other half. And so then I moved back to Montana State about 15 years ago. And so I'm a professor here in electrical and computer engineering, and my research interest, my teaching interest is in this area of digital systems. So everything to do with logic and programmable logic devices and all that sort of stuff. If you go out here, you'll see I've listed a bunch of stuff from my projects, like news articles, podcasts I've done. But my research is really focused on using programmable hardware fabrics. So hardware that can change in real time. Okay, and you'll learn about this in this class and the following classes. But if you can do that, it turns out that you can optimize computing systems on the fly. So instead of having like a general purpose processor, you can have a custom processor, and then when the application changes, you change the hardware and it's now optimized for something else. And what happened was this caught the attention of NASA about 12 years ago, and they said, when you reconfigure your hardware, you're actually flushing out faults that may have occurred. And I said, yeah, that's true. And they said, we have a problem with faults in outer space because ionizing radiation strikes our computers and causes bits to flip and causes computers to crash. So what happened was that they started funding me to do projects where I would test out different novel architectures and then fly them to demonstrate that. So we've done things like built this little computer that we've invented called RadPC. We've flown it on sounding rockets. I've got a bunch of pictures on here. Let's see, it's been on the International Space Station. There's actually 2 small satellites that are carrying this computer I've been working on that are in orbit as we speak. I've done high altitude balloons, like balloons that are the size of a skyscraper type thing. This is a picture of what the satellites look like. They're about the size of a loaf of bread. This is it getting pushed out of the International Space Station. Here's me and my students out there watching the launch. But notice that the MSU cat head is on this, and you can see the cat head in these pictures. Same thing with the M, and it's getting pushed out of the ISS. So, awesome. Anyway, this computer has actually been selected to be demonstrated on the surface of the moon. And so we're going to be in 2023, hopefully an MSU computer that was designed in my research lab will actually be sitting on the moon and testing our architecture. So that's my background. I just want to say it's like digital logic. That's my thing. So I chose that as my area of study in school. I went to work as a digital hardware designer. I got my graduate degrees in digital systems. I do research at MSU on digital systems. I teach in digital systems. I wrote the book on digital systems. If you take other classes, I've written a series of books in digital systems. So this is really my area of passion. Okay, so and I only want to teach you stuff that you will actually use. And so based on my time in industry and the research that I do and my students do, I'm not going to teach you stuff that's just junk, okay? This is stuff that you will use. This is a tangible skill, okay? All right, so that's what I am. So now, what is a Brian? Who did that? Okay, so now let's talk about the course, okay? So let's go through the programmatics of this course. This is the syllabus, and this is in Brightspace, but I'll show you where to get that in a second. But I want to go over this. Let's see, description, I already told you. Learning outcomes, like I say, everything I teach you is to give you the ability to demonstrate that you can do something. So it's always like, you will be able to describe this. You will be able to perform this. You will be able to read and understand a data sheet, synthesize. So these are specifics of what you're going to be able to do after this class. I am located, my office is in the new engineering building, so Norm Asbjornson Hall. And so, yeah, and we have a teaching assistant. So you're probably going to interact with the teaching assistant more in person than you will with me. It's McKenna Landis. She's in 511 Cobley. Here's her email right there. And now, so between the two of us, we're going to administer this class. Here's the big thing. Spring 2021. We are still in COVID pandemic mode. It's unfortunate. It sucks. I hope that this is the last time we have to do anything like this. But we are going to teach this class in a blended format. What that means, blended means some live, some online. Your lectures, instead of coming to a class and listening to me talk, you are going to watch videos of me talking. So I've made a set of YouTube videos that replace the lecture part of this class. There is going to be no meeting time for the lecture. Even though in the My Info registration it says we have Monday, Wednesday, Friday from 9 to 9:50, we are not going to use that time. That is just a reserved slot so that if I wanted to like do WebExes with you, we could, but I'm not gonna. You are going to be given this set of videos each week, and you will work through the material kind of on your own pace with weekly deadlines, okay? And we'll talk about that. However, there is a live lab section that you registered for. So you registered for these lab sections on Tuesdays between 2 and 6, so you got a 2-hour slot. What we are going to do is the labs are going to be conducted with a kit, a lab kit. And the lab kit is portable, meaning that if you have a laptop running Windows, that you can do the lab from anywhere. And it's totally possible to do this. I've been teaching this class online for about 5 years. I have people from all over the country that do this class. All you need is a computer and some of the lab kit and some free software. And so the reason we want to do that is because you can come to the live lab section and you can work in the lab and you can get help from McKenna. Okay, so she is going to be there if you need help. We're not going to have labs where it's like you come to lab and you do this specific set of tasks and then you demo. It's like, demo, I'm done. We're not going to do that. You are going to actually demonstrate your circuits by recording a short video with your phone. And then you'll upload, pictures of your work, videos of your circuitry doing stuff. And the reason we're going to do that, you do that whether you're live on campus or off campus. You always turn in the material for your labs the same way. The reason we do that is, number one, if COVID forces us to shut down campus again, this class will not change whatsoever. Okay, that you have all the materials. We're just going to keep cranking through the schedule just like it is right now. You don't have to come check anything out. We don't have to do anything. We're already doing it right. But you are absolutely invited to come to the lab sections and use them as an open help session. So McKenna's going to be there. She's going to be there, or she'll be on WebEx. She's actually going to come to each lab section, and then she'll also open up WebEx, so that if you're working off campus and you need to help with something, you just WebEx into her room and then wait for her to come around, and then she'll help you. The reason we want to do it this way is to simply reduce the number of students that are coming to campus, okay? Because less students means you can spread out. And so some courses we're able to teach in this manner, some aren't. This is one that we are going to do it, okay? So the labs are going to be considered open help sessions. Now, not mandatory attendance. So what I've found in the past is some students will come to lab and they like being in lab and they like having that dedicated 2-hour block, and they like having someone like McKenna that can help them right away. You are absolutely invited to do that. That is your time, okay? Some students say, I don't want to come to campus. I don't have to come to campus. It's kind of a pain, and I can do the labs at my kitchen table or in my dorm room. That is absolutely fine too. Some students do everything remotely, and then when they have a problem, they'll WebEx in and talk to McKenna. That's fine too, as long as you do it during your lab section slot. And finally, some students work mostly remotely, and then when they kind of get stuck, they'll drop into the lab and then they'll get help live. And that is fine too. So in summary, no fixed meeting time for lecture, and the labs are open help sessions. You are going to get a kit that will allow you to do everything remotely if necessary, but you can bring that kit to campus and sit in the lab and do it, okay? Here's the materials you need. You need a computer, obviously. You're not doing college without a computer anymore. Laptops, obviously, is the best, so you can cruise it around. But you got to have a Windows machine. I'm going to tell you right now, if you're going to be an engineer, you got to get rid of your Mac. Okay, the Mac thing, engineering software doesn't run on a Mac. Every once in a while, you'll see a tool that runs on a Mac. But just get rid of that stupid Mac. It's going to just kill you if you're trying to get an engineering degree, okay? Our software doesn't run on a Mac, so you're going to have, once you come to the point about halfway through the semester and you start trying to install the software and trying to get the software to work, you're just going to have this huge headache. So toss the Mac if you're in engineering. You need the textbook, okay? So the textbook, I wrote it. It's called Introduction to Logic Circuits and Logic Design with VHDL. This actually covers this class and the follow-on class, which is 367 Logic Design. If you want to buy a hard copy, click on this link right here, okay? This is also on the website too. But what I did is, it just turns out if you buy it through this, my associate ID link on Amazon, I get like a penny or something. So I'm going to add up all these pennies and someday have $1. But anyway, you can buy it straight through there. Amazon always has the lowest prices. They beat the bookstore every time. It's pretty incredible. Then you're going to have a lab kit. And this is important because your lab kit consists of multiple things. First and foremost, you have to buy something. You have to buy a large breadboard. And these are $20. You're going to buy it on your first day of class. You're going to come, even though I said that attendance is not mandatory, it is on the first day. So on Tuesday, the January 12th, you need to come to your lab section, and we're going to introduce you to myself, to McKenna, and then we're going to march you over to the ECE office, and you are going to buy your breadboard. And then once you have your breadboard, for $20, we don't have a credit card reader, so you have to bring cash or check. We can't take your credit cards or CAT cards or anything like that. But you got to buy this breadboard, so bring a $20 bill. And that breadboard can be used for the rest of your time at MSU, okay? So you're going to have, all your classes are going to have labs. You're going to need a breadboard, so you use this thing forever. Then we're going to check out to you something called an analog discovery, okay? And this is going to allow you to plug into a USB connector on your computer, and it's going to allow you to get power to your breadboard. It's going to allow you to drive in signals. It's going to allow you to observe signals. So this is the magic piece that allows us to do everything remotely. And then finally, you're going to have parts. You're going to have little discrete circuit parts or circuit components. We're just going to give those to you. So things like LEDs and resistors. And so for the labs, we'll give you what you need. And then hopefully we'll have like a parts kit that we give you once our stockroom person gets back. And then you need a camera capable of taking short videos. So this is a smartphone, but literally you are going to be sitting there. Here's my circuit. I'm moving switches, and you're going to be sitting there with your phone, doing a video, and then you upload it to Brightspace, and that's how you get demoed. Okay. All right. Brightspace is the main thing. The prereq for this class is just college algebra. Okay. There is no like electrical engineering circuit background or circuit prereq. So everything that you need to do with electricity, I try to give you enough background in the labs to get you going. So office hours, there's no real office hours. Use those lab sections. I know you're registered for the lab sections, so I know you have a 2-hour block dedicated to this class. So don't get in the habit of trying to work at like midnight. Use those 2 hours for your help session. So that's there for you. Homework, grading. We're gonna do homework in the form of multiple choice quizzes and some simulations using the VHDL. And that's worth 25% of your grade. Labs are the big one. They're worth 45% of your grade, and yeah, they're awesome. And then you're gonna have these end of module quizzes, and these are kind of like a replacement for short exams. So at the end of each module, we'll have a little quiz. Exams, we're gonna have one comprehensive exam at the end worth 10% of your grade. The points are, I have everything broken out to be worth 1,000 points. And so what you'll do is as you complete assignments, you'll just see your total points go from 0 to 2 to 5 to 10, and you'll build up until you get 950 or 1,000 points and you get your A and you're done. I grade straight. I don't like minuses because there's no A+. So if you get a 91, you get penalized, you get an A-, but if you get a 99%, you don't get an A+. So I'd never give minuses. Sometimes I'll give a plus, but I hate minuses. The stuff you will be doing. You will be reading the book and watching instructional videos. These are actually the same material. I wrote the book first, then I recorded the lecture videos after. So it's the same material. So some people like to read, some people like to watch videos. Sometimes it's just you can't capture everything in a video. Sometimes you can't capture everything in writing. So these two are the same material. So it's what I would recommend is whatever format you like to use and get used to, but always have the other one ready. So like you can reference back to the book if you're only watching videos. Okay. Homework and multiple choice quizzes. End of module quizzes. Let's talk about this really quick. There's a tool in Brightspace called quizzes. And sometimes you'll have a homework that is a quiz, right? It's a multiple choice quiz. So then you'll have an end of module quiz. So what's the difference between the two? Well, a homework is something that has a deadline, but you can open up the quiz, read it, and you can enter your answers, and then you can save it, and you can leave, and you can come back to it and work on it again. It's not timed. The only time component is that it has a deadline, and after the deadline, the quiz will disappear. So you got to make sure to submit it before your deadline. End of module quizzes are more like an exam. They emulate what it would be like if I came in with a piece of paper and said, let's do a quick exam. They are timed. So each of these end of module quizzes, there's 7 modules, you're going to take 7 quizzes, is timed. And they range between 30 minutes to 90 minutes, depending on how long the module is. The biggest problem is, not a problem, but the biggest thing to keep in mind, you have to make sure that if you start the quiz, you have time to finish it because the timer starts when you start and it goes away. So if you start a quiz, end of module quiz, and then you log out of Brightspace, it doesn't matter. The timer keeps going, it expires, you get an F, okay? So you just got to make sure that you give yourself enough time. Okay, final exam is also going to be a timed multiple choice quiz in Brightspace. Academic policies, the biggest challenge with academic policies these days is in engineering, no problems are solved by an individual anymore. So we're trying to teach you to collaborate and work together to solve problems. So you're encouraged to collaborate, to work together on homework, work together on labs, and that's great. But there's also this component of you have to show your own work. So the difference between collaborating and cheating is where you turn in somebody else's work or you just copy their work verbatim. So you can work in a group, let's say 10 people are sitting around like, how did you do this? And somebody's showing you how to do it. And that's fine, but everybody needs to do their own work. You need to write out write out your solutions yourself, type in your own code, do your own quizzes. But cheating is where you just say, give me the answer. Okay, so don't cheat. Now, got to wear masks on campus. You already are aware of that. And now here's this big one. Okay, this is important. At the end of the syllabus, you will find all of the assignments, all of the activities, if they're graded and when they're due. This due date is critical. This is what every time you log into Brightspace, you should have this in front of you so you know what you're supposed to be working on and when it's due. I put all the deadlines due the following Tuesday at 6 p.m. Okay. Except the first one. Okay, the first one is actually due the first Tuesday of the semester because I want you to show me you can log in and actually can find where everything is. But under a normal week, you will have activities to do. So here's section 1.1. You're going to have a video reading assignment, and then there's a homework, and it's worth 1 point. 1.2, you got videos and homework, videos and reading and homework, and it's worth 2 points. Notice that they are due the following Tuesday at 6 p.m. Now you go, why in the world is Tuesday at 6 p.m. what you chose? You should be able to do all these activities during the week, during week 1. But if something happens and you don't get them done, that gives you the weekend and the following Monday and the following Tuesday lab section to get help. 6 p.m. represents when the lab sections of the following week end. So that's why everything's due the following Tuesday at 6 p.m. if you scroll through here. So even the lab and even the end of module quiz. So the first week you're going to do this course logistics online environment, just a little, basically just a little multiple choice quiz that proves that you watched this video. And it's just to show me that you know how to log in. Then you're going to crank through module 1. Week 2, you're going to do module 2, which consists of 4 sections that include videos and quizzes and homework and stuff like that. And you have a lab. You also have a lab during the first week. You have a lab during the second week. And notice that the points associated with these are all different. Some homeworks are really simple. Some are more involved. Some of the labs are simple, some are more involved, and some of the quizzes are longer. So you'll notice that the points kind of reflect like how much time and effort that you're actually putting in. But if you scroll through this, it's just repeat, repeat, repeat. You just get in this rhythm where it's just like, oh, week 2, here's my activities. I plan out my week of when I'm going to do them. I know that I have an open help session on Tuesdays if I need. I know if I fall behind, I can use the lab section on the following Tuesday. But everything's due the following week at 6. And we just crank, and we 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 crank. There's no spring break, so we just keep cranking. And finally, we get down here, and we get to week 14, and you have your final exam. This class is over on April 20th. That is going to be the last week of class officially. We're going to be done Tuesday at 6. And then there's a final week, but we're going to be done about a week and a half before the rest of campus. That'll give you time to do your finals in the other classes. But this flow right here is critical. This is the most important part because this tells you when everything is due. Finally, let's go back into Brightspace. So you log into Brightspace, website's on the syllabus. You come into here, all your courses are in here. You go ahead and you click Intro to Logic Circuits. And here you are. I put an announcement right here that's kind of a welcome. When I email you every week with a reminder that says, this week we're going to do this, I'll also put it in the announcement so that you kind of have this running tally of what's going on. Everything in here is linked to content, okay? So this, if I come up to content, I'm going to see a page for every module. I have the course information and syllabus, I have module 1 through 7, and I have the final exam. Okay, so if I look at information in syllabus, you're going to see the same information we just covered, but it's got links to things. Okay, so like for example, here's the introduction paragraph, but here's the link to the syllabus. So if I click on that, lo and behold, the syllabus comes up. If I come over here, I have the first assignment right here, course overview quiz. If you click on that, it takes you to the quiz. All right, life is good. Come down here. Here's me and McKenna. Here's our email. And here is McKenna's WebEx session. So during the lab times on Tuesdays, if you need to get help from her remotely, this is the WebEx room that you use, okay? Email is the preferred mode of contact, but you should always email both of us, and then we will try to that allows us to get back to you faster. McKenna's going to be doing all the grading, so you don't want to email me about grades and leave McKenna off because she's the one in charge. All right, here is the book again. Here's your link to the Amazon page. Load those pennies up for me, and then this just repeats what we said. Here's a normal looking module. Okay, so here's module 1. Notice that I start by saying learning outcomes, what you're going to be able to do, and then here's your activities. Section 1.1, read, watch a video, do the homework. Section 1.2, read, watch the video, do the homework. Laboratory, go ahead and click the lab, watch an overview video of how to get you started, and then do it, take a video and upload it to the assignment folder, and then come back, do the module quiz. Let me show you what the module, the lab descriptions look like. When you click on it, you're going to download this massive PDF that I created, okay? You only need to download this once, because if you look at the table of contents, this is all the labs for the whole semester and also the labs for the next class if you want to see what's happening. But here's chapter 1, chapter 2, chapter 3, chapter 4. Notice chapter 4 has 3 different labs. But let me give you an idea of what a lab might look like. Okay, so it tells you all the parts that we're going to give you. So here's like an example. So here's lab 1.1. You go through here, you're going to build this circuit. Here's your breadboard. I tell you how to like put the wires in it initially. I get you going with the breadboard. We talk about what the resistor is that you're going to stick in there. I give you an LED. I give you all the information on that. I show you exactly how to do it and how to wire it in there. And then you use this instrument called the analog discovery, plug it in, control or install the software, and you're able to drive in a signal and make the LED blink. So that is an example of a lab. Okay, and then you're actually able to take measurements on it. I know I'm cruising through this fast, but we're almost done. You can look at the signals, and so when you're done with this, like the deliverables are videos and pictures and screenshots, and you take all those files and you got to upload them. So you go over here to the assignment folder, click it, and you upload all the files to that, and then we grade it, and you'll see your grade pop up. And that's how you're going to do every lab. This lab can get more and more complicated. Let me show you like a picture of some of the more complicated ones. So like here's an example of a circuit where you are actually putting circuitry down, chips down, you're wiring them up, you're still using the analog discovery. So you're gonna be doing these labs that can get pretty intense. Okay, they're pretty awesome though. Okay, let me see if I have a really big one to scare you. Don't be scared. This is actually really fun, and we really walk you through everything. So like, yeah, whatever. Okay. Anyway, so that is the Brightspace situation. All the tools up here are also active. So like you can look at your grades right here. You can click on grades and you can see what the grades are. Yours will have like your points. You start at a 0. Don't feel like you're failing on day 1. It's 0 out of 1,000, and you just add your points up. So you can always see your grades. Homeworks, quizzes are automatically graded and your points go right away, but the labs, we wait till the deadline and then we do them. Quizzes, if you click on them, you can see all the quizzes, but reality is it's better to access everything through content because the content page has everything linked. So even though I come over here and I say, if I click on this, it's a quiz, I could get to there from here, but it's like everything's linked here. And that allows you to say, this one takes me to a video. This link takes me to a quiz. This link takes me to a PDF. This link takes me to an assignment folder where I can upload things, but I never have to putz around in any of the tools. I just go ahead and just do everything in here. Okay, so that is it. And you just crank through these things, module 2, module 3, module 4. You can notice that some of them have a lot more videos because they take more time. Module 4 is 3 weeks. But anyway, that is it. So now what we are talking about is you are prepared to start. So right now, if you're watching this video, go do the course overview quiz that's due on Tuesday, the 12th of January at 6 p.m. Okay, go do that. Watch how you submit a quiz. Watch how the points pop into your account. On Tuesday, actually on Monday, start on module 1. So start working on this class. On Tuesday, okay, the 12th, go to your lab section because we need you to get your lab kit. We're gonna introduce ourselves and march over to the EC office, and then you will have your lab kit. But after watching this, you can engage in the class. You can start working the material right away and have an awesome time. Okay, that is it. Good luck this semester. I look forward to working with you, and goodbye.